Hi, in this video, I'd like to look at compound interest. Before we start, I'd like to brush up on simple interest. Simple interest means that an amount increases each year by a percentage of the original amount. We looked at an example where Jack invested $100 into a bank account at a rate of 10% per annum simple interest. So let's see how much that is. 10% of $100 is $10. So each year, Jack's money increases by $10. After the first year, Jack had $100 he invested plus $10 in interest. So he has a total of $110. After the second year, Jack has $110 plus another $10, and we get $120. After the third year, we have $120 plus another $10, and we see that Jack has $130. From this, we can see that Jack's money increases by $10 each year because $10 is 10% of the original amount. Compound interest works differently. With compound interest, an amount increases each year by a percentage of the amount currently in the bank. So let's see how much Jack's money will increase if the bank offers him compound interest. Jack invested $100 and the interest rate is still 10%. And we know that 10% of $100 is $10. So after the first year, we can take Jack's original amount, $100, add 10%, which is $10, and we get $110. This amount is the same as Jack had after 1 year using simple interest, but from here, the amounts will change. After the second year, Jack will have $110 in his account plus 10% of this amount. So let's see how much this is. So we can say 110. Let's change 10% into a decimal. We say multiplied by 0.1, and we get $11. This is the amount that will be added to Jack's account. So we say $110 plus 11, and we get $121. This is the amount Jack has after 2 years. Now let's see how much Jack has after his third year. The amount will increase again by 10% of the current amount. So we can say 121 multiplied by 0.1, and we get $12.10. This is the amount that Jack's money will increase by. So let's add it to the existing amount, and we say 121 plus $12.10, and we get $133.10. This is the amount that Jack will have after 3 years. This is a very simplistic example, but working with compound interest this way can become a lot more difficult when we have larger amounts and longer durations. It would be extremely time consuming to determine how much money Jack has after 25 years. So to make it easier, we can use the compound interest formula. This takes on the format A is equal to P, open our bracket, 1 plus I. Now, this is very similar to the simple interest formula, but in this case, instead of multiplying I by N, we close our bracket and we make N our exponent. Here, A is still the accumulated amount at the end of the investment. P is still the principal amount, it is the amount you put in to the investment. I is still the rate of interest, calculated as a percentage over 100. And N is still the duration of the investment, calculated in years. To find A, we start by adding 1 and I. Then we find the value of the bracket to the exponent of N. And finally, we multiply everything by P. Let's look at some examples. Susie invested $50 and the bank offered her an interest rate of 20% compounded annually. How much will Susie have after 5 years? The question is asking us to find how much Susie will have at the end of her investment. We are looking for the accumulated amount, so we need to solve for A. Let's find our P, I, and N values. Susie invested $50, which is her principal amount, so P is equal to 50. The bank offers her an interest rate of 20%, so to find I, we say 20 over 100, and we get 0,2. Susie invested for 5 years. That's the duration, so N is equal to 5. Now that we have these values, we can put them into the formula. So we say A is equal to P, which is 50. Open our bracket. Then we have 1 plus the value of I, 0,2. Close the bracket to the exponent of N, which is 5. Now we have 50 outside of our bracket. Inside, 1 plus 0,2 gives us 1,2 to the power of 5. Now we have 50. Open our bracket. 1,2 to the power of 5 is 2,48832. Finally, let's multiply the bracket by 50, and we get 124,416. Now remember that the value of A is money, so we can take this amount and we round off to 2 decimal places. We get 124,42. Don't forget your currency. And our answer becomes $124.42. When working with decimals and exponents, you may get a very long answer when finding the value of the bracket to the exponent of n. In many cases, you will get answers where a single value is followed by 10 or even 20 digits after the decimal place. Please do not round off. This will lead your final answer to be incorrect. Now, copying down all of the digits after the decimal place can be time consuming, especially in an exam situation. So, to make it easier, you can use your calculator, skip this step over here, and just carry on from this value over there. Let's do another example. Peter invests $1,500 with his bank. The bank offers him an interest rate of 7% compounded annually. How much will Peter have after 4 years? The question is asking us to find how much money Peter will have at the end of his investment. So we need to solve for A. Let's find our P, I, and N values. Peter invests $1,500. That's the initial amount. So we can say P is equal to 1,500. The bank offers him an interest rate of 7%. So to find I, we say 7 over 100, and we get 0,07. Peter invests for 4 years. So the duration, so we can say N is equal to 4. Now that we have these values, let's put them into the formula. And we get A is equal to P. 1500. Open our bracket, 1 plus the value of I, 0,07, to an exponent of n, which is 4. Now we have 1500. Open our bracket, 1 plus 0,07 gives us 1,07 with an exponent of 4. Now we can take 1,07 to an exponent of 4. Then we multiply by 1500 and we get an answer of $1,966.19. This is the amount that Peter will have after his investment. Let's do another one. Shelley takes out a loan of $8,500 that she will need to pay back over 5 years. The bank offers her an interest rate of 6% compounded annually. How much will Shelley have to pay the bank? This question is asking us to find the amount that Shelley owes the bank. So again, we need to solve for A. Let's find our P, I, and N values. Shelley takes out a loan of $8,500. The initial loan takes on the value of P. So P is equal to 8,500. She will need to pay back the amount for 5 years. That's the duration. So N is equal to 5. The bank offers her an interest rate of 6%. So to find I, we say 6 divided by 100, and we get 0,06. Now that we have these values, let's put them into the formula. And we say A is equal to P, 8,500. Open our bracket, 1 plus the value of I, 0,06, to the power of n, which is 5. Now we have 8,500. Open our bracket, 1 plus 0,06 gives us 1,06 to the power of 5. Now we can take our calculator, 1,06 to the power of 5 multiplied by 8,500 gives us an answer of $11,374.92. Remember to always round your answers to 2 decimal places. Let's do one last example. Timothy wants to retire in 25 years. He puts $26,000 into a savings account at a rate of 14% compounded annually. How much money will Timothy have when he retires? We need to find the amount of money Timothy will have when he retires. So again, we need to solve for A. Let's find our P, I, and N values. Timothy wants to retire in 25 years. This is the duration of his investment. So N is equal to 25. He invests $26,000. It's the principal amount. So P is equal to 26,000. The bank offers him a rate of 14%. So to find I, we say 14 over 100, and we get 0,14. Now that we have these values, let's put them into the formula. And we say A is equal to P, 26,000. Open our bracket, 1 plus the value of I, 0,14. Close the bracket to the power of n, which is 25. Now, outside our bracket, we have 26,000. Inside the bracket, 1 plus 0,14, which gives us 1,14 to the power of 25. Now we can take our calculators. 1,14 to the power of 25 multiplied by 26,000 gives us $688,009.81, rounded off to 2 decimal places. And we have now completed this question.